So up. That's it. So who am I? If you were there yesterday, you already know me. If not, I am Frédéric Descamps. I am living in Belgium. I'm using MySQL for 28 years now, so it's a long time, not 30 PT. So you can find me in social media if you want. You will have the slide to find that, or you can reach me out outside whenever you want. So what is this session about? So first, I would like to apologize. This session will be a lot of content. So I will try to not skip slides, but there is a lot. So, but then I wanted to keep everything there, so you have the chance when you get the slides to take a look. So it's about speed and performance. Nobody ever complains the database is too fast. Maybe if you are using Kubernetes, it could happen, but if not, no. That was a joke. And it's often the reverse. Like everybody blames the database, and but speeding up the queries is not really a dark art, but people think it's quite magic, and it could looks like magic, but it's not. So we will try to figure out and to understand the mechanisms to make it happen. So we will look what techniques are and how to use indexes to get a very good workload when it's possible. So in this, so please don't try to get all the queries I will show you, because there will be plenty of nice queries, because we have all the instrumentation required in MySQL. But you will find the slide, I'm sure, on the summit page you will have the slide, but in case not, on my speaker deck you will have also the slide. And today we will not discuss at all about system configuration, operating system, MySQL configuration, hardware, networking, cloud. I will not talk about that. If you have questions related to performance on these topics, just ask me outside. I'm also at the MySQL pod a lot of during the conference, so just go there. So first, let's talk about the North Star, so the query response time. So you may have seen yesterday Daniel here on stage. So Daniel Nichter wrote Efficient MySQL Performance, and I wanted to quote him a bit about the query response time. Is the only thing that as a user you can feel, right? This is the only thing you feel. You don't feel, oh, this is a table scan, or my database did 2,100 IOPS. As a user, you don't feel that. But you say, oh, I was on the page and it took 2 seconds to load. That is something you can feel, right? And so this is what is important for all DBA and developers. It's the time of the response. So you make a query and how long it will take to get the response. So this is what you should focus and see what's really important and what's matter. So what's matter is just the response time. So if you do even something it's bad, but it's fast, why not? So the goal is to reduce the query response time. So to reduce the query response time, the first thing we need to do is, of course, to find who are the bad queries, right? So we can define 2 categories of bad queries when you create an application. And this is not only for MySQL, this is for all databases, right? And these 2 bad type of queries is the queries that are called way too often. So if you have, let's say you have a query that takes 2 milliseconds, could be fast or slow, depend from how many times you are a DBA, I would say, because 2 milliseconds could be very slow. But you can say, oh, 2 milliseconds is okay. It's fine for me for this query. But let's say that for one page, you call this query 10,000 times. That's way too long at the end, right? So this query, you need to track them and say, oh, I'm calling this query way too often in my application, so we need to find a way to reduce that. And then the other type of queries is the queries that are slow by themselves, and that queries that make full table scan, that are doing file sort, for example, or that are using temporary tables. Most of the time, this is the kind of query that are very slow. So for MySQL, and the thing is, why is it an issue? The issue with MySQL, and this is why MySQL is so popular, is that you can write bad queries. Yes, you can, and it will work. But at the end, you will pay the price when you go at scale, right? So this is, I really like this image that MySQL is not scared about almost anything but full table scans, right? So if there is one query, and this is what I always say to DBAs and developers that are also managing their database, if there is one query that you need to try to fix is, and you should do this exercise once a month or once a week, or if you're a dedicated DBA and you have time, maybe do it every day, is you need to find the query that is consuming the most response time. So in Schema, you have all the necessary information to find that query, right? That what I call the ugly duckling, le vilain petit canard in French. So this is the query. So you run this query. No need to take a picture. You will have the slides. But you run the query, and this query will return something like this. Okay, there is a schema by day. The latency, so the response time for this query was 4 hours and 29 minutes, and it was executed 5 times only, and you can see the latency per call in average, it's 51 minutes. And then you have a sample text of the query. So this query, it's way too long, right? So now, as a DBA, I should fix this query. We will see how we could fix such a query later, but this is the information you get. So you run that query, you see what comes out, and this is where, as a DBA, you need to, the query you need to fix. Schema also contains plenty of other nice tables that helps you, as a DBA, to find all the queries that you have an issue with. So we have a table that's called Statement with Full Table Scan. The name is long, but it's quite very understandable to what's inside. So it's all the statements that are doing full table scan. So we have also a statement with doing a file sort, temp tables, and you can get in a 19th percentile runtime, so how long they are taking, all the queries there. So you sort that by the time, and you will find the longest one. And something very cool is that since MySQL 8, so if you are trying this before MySQL 8, you would have a digest output so of the query, and then, but you cannot execute it, you cannot explain it, you cannot do anything with it because it was like kind of normalized. And, but now you have also a sample when you join this table, and you have the output that I just showed you. So, and we will, meaning this, we will work on this table after. So something people doesn't like to hear, but it's so true, it's that the problem, it's not the database most often, the problem is the query, right? These are the academic slides, so I will try to not spend too much time on that, but we should know some stuff. It's that we should consider the optimizer as the brain of MySQL. So query optimization, and when you run some query, the optimizer will try to do the best job as possible it can do. And, but to do that, it will do plenty of stuff, and it will try to find the best way to execute your query. I think if you have been yesterday, there was a session on the new optimizer. You should have seen some ways on that. And so what does the optimizer? It will estimate the cost of the query and you as a DBA, and depending how your table are designed, you will interfere with this and you will create more data, and we will see later there are more plans, and this takes time, of course, right? And the cost of a query is the result of some mathematical models that only this guy understands, and he's over there in the room. So if you have questions about this, just ask Norvald. And this is what the optimizer do usually. So of course, the optimizer will try to find the cheapest way to get your data, and it will try to create this plan. And at the end, the plan that it will select is what we call the query execution plan. And if you come from the Oracle database, Oracle database, you can save query execution plan for queries and stuff like that. And once you get it, you can run your query, and you don't need to find to create that execution plan anymore. It's not the case in MySQL. So in MySQL, every time you run the query, the optimizer will try to find and recreate the query execution plan. So if your query, in your query you do 5 joins, for example, the optimizer may evaluate 120 different options. So you need to think about that. And please remember that for some slide I will show you later, I will just say, oh, remember what I said about the optimizer, and this is this slide. So, as I said, the query execution plan, you get it, it's what the optimizer decided to run your query, and with explain, you will find that information. So, who never heard about explain in MySQL? Perfect. So we will be able to skip some of the slides. So explain is the command to obtain the query execution plan, and we have changed explain. We are improving it all the time. So Norval's team improves that, and I will show you some output and how to use it. So this is an example of a query with explain. So I run explain command just before the query. I use \G here to have a vertical output, which is easier on slides. And we can see that here is the query plan, and then you have extended information, how maybe the optimizer changed stuff in your query. So we see that it has which table we are using, which are the keys that you are using, but we will see some of information later together. Something very important when you run explain is that this is an explanation and an estimation on how MySQL would run the query. So it means that the query, when you run explain, is not executed. So this is not dangerous to run unless very rare case to run a query. If you have a sleep in your query, that's a bit different, and you should not. But so you can run that in production. Explain, no issue. It's just the estimation, and you have what the optimizer thinks is the best to run the query. And these are the access type, and from the most optimal one to the worst one. So meaning that I will not go into the details of all of them because you will have the slide, but when you see whole at the end is the worst. So this is why you should try to avoid as much as possible. And if you want to have an example of each of the types and stuff, I also recommend to read this book, which is MySQL 8 Query Performance Tuning from Jesper. So very nice book. So we show the first explain. Here I show you an explain with join. So now we have two rows. So row 1 for first table, and then row 2 for the second table. And here, for example, I was doing select star from city, join country, but the optimizer decided, oh, country is the table that I will check data inside first, and then I will use the city one, right? We changed another format for explain, which is the format tree. So like if you are a Postgres DBA also, or if you have experience with Postgres, this is a format that is more familiar than the previous one. So we have also the format equal tree. So you have the output like this. And this is another example with the join of the format equal tree. Then we have another format, because like I said, we are improving the explain output. So here is the JSON one. So this is the most detailed estimation compared to the previous one. So you have plenty of information about the query plan in JSON output. And I will explain you here that also since MySQL 8.2, we have a variable which is the explain format. You can change it there, and you can set it whatever you want. You can also do an explain for a schema. So I mean you can be in one schema and make a query from another schema. That will work. And you can also change a new format version of the JSON. So here we have the explain JSON format version 2, which is the latest one. I don't know if you have planned to have a third one, Norvald, but currently this is the latest one and also the most detailed. So you do set explain JSON format version equal 2. You can put, you can do a set persist if you want to persist always and use always this version. And then you can do the explain to have the format 2. And this is what you get with the new format, right? And something also that we have added when we use the JSON format is that you can save the explain into a variable. So this is all, and then you can use that variable to do whatever you want. And this, in this example, for example, I am creating a variable that I call my query explain plan, and I do the explain in it, then I do the select, and I will extract just the estimated total cost for the query, and I have the query cost, and I can use it, save it, whatever I want to do. So these are all estimations. Now, can we know the real numbers? So you say, oh, it estimates that you're going to read that many rows and stuff, and, but could we know the real numbers? And in fact, yes, we can. With explain analyze. So in MySQL 8, we have added explain analyze, and we will see the estimation, but also the execution. So that means that when we do this, we instrument the query, but we also execute the query. So if you have a query that takes 51 minutes, like the one I showed you earlier, and you do explain analyze and run the query, this explain analyze will take 51 minutes at least, right? And then we have this. So this is an explain analyze of one query. And we can see here, we have the time to get the first row, for example. Then this is expressed in milliseconds. Then we have the actual time to get all the rows and the amount of rows that we retrieve there. Then if there were some loops in there, how many loops we have done here, one loop, and so on, right? You can also, as a DBA, and this is nice for the DBAs, you can explain for a connection. So you will see that there is a connection that is running for a long time. You could say, oh, explain for that connection, and you will have the query execution plan of the query that is running in that connection at that moment. So this is very, very nice. So if you want more information about explain, there was the book that I show you, but you can also find a lot of information in the manual. So this was about the query execution plan, and we will see how to work with it after. So the session is about indexes and histograms, because this is what we're going to use to make the query faster. So in MySQL, we have a different type of indexes. We have B-trees, hash index, R3 indexes for the spatial data types, and the inverted list for full text. Full text search, I will not talk about it today. And then all the index, they have also properties. Like an index can be a prefix of a column, can have multi-column. An index can be unique, can be a covering index, a functional index, and a multi-value index. So we will check that. But the first index that you will encounter when you create a database in MySQL, and you should use InnoDB. So if you are using another engine like MyXam, you should run and change that as soon as possible to InnoDB. So every InnoDB has a special index that is called the cluster index. And this is all the data it's stored in the table space. And we usually call that cluster index the primary key of the table. And it's in bold there, maybe not even bold enough, but primary keys are very, very important in MySQL when you are using InnoDB, and you should have primary keys. So I want to show you some impact of having bad primary keys. So here for example, I do an insert, so inserting data in one table where the primary key is completely random all the time. And what we can see here, that every time we are inserting data, we are touching almost every pages because we need to rebalance the index. So for example, here, maybe we need to add some data in the fifth page. So, but the fifth page might be full, we will need to split everything to put it there and move everybody else. So this, it's very costly. People doesn't see that, doesn't understand that, but this is what happens. So you should monitor that. You should have good primary keys. If we do exactly the same exercise, but with a good primary key which is incremented, so meaning that the next value will be after the previous one directly, this is what we have. So only the latest pages and first pages are modified. All the rest, it's called and might be not touched forever, right? So this is what you should have. And this is where the primary key, it's one of the facts why the primary key is important, but there are other stuff. So as a DBA, if you ask your developer, please add primary keys, and you see that they still don't do it, you can annoy them. It's easy. You just do SQL require primary keys, and every time somebody will create a table without primary key, what will happen? It will get an error. So that's nice. Then, but it was not enough. People say, yeah, I don't want to run your errors, but I try to convince a developer to add primary keys, and they never want to add primary keys. Since MySQL 8.3, we have the GIPK mode. Who never heard about GIPK mode? All of you heard about it? No, some? Okay, good. So GIPK mode means generated invisible primary key. So you can tell MySQL, hey guys, if somebody creates a table without primary key, create it for me. And this is what we do here. So we have a variable called SQL generate invisible primary key. And when we enable that, every time somebody creates a data, it will have the primary key. So here I put it to 1. I create a table without primary key at all. I am inserting data, and you can see there is no primary key here in this case. But if I check how the table is created, we have my row ID, which is invisible, created there and used as the primary key. So for the application, nothing changed. The developer, they don't even see it. But for the DBA and for replication, for everything, that primary key will be used. So this is very, very important. And if you want, you can see it by just adding the my row ID on your query, and you will get it. But if not, it's completely hidden. You can have it in information schema. You can see it there. And sometime when we did that, people say, yeah, but we have a legacy application that does something that me, as a MySQL DBA, I don't like, but it's, I create my application by checking information schema and see what are the fields in the table, and I display a form, for example, out of it. And now that you have this my row ID, everything it's screwed up and it's broken. What can I do? It's easy. You can use one of the longest system variable in MySQL called show GIP key in create table and information schema. And if you put it to 0, then what happens? You don't see it. So your table, your application won't break because it's gone. You don't see it, right? Same here. So we have it. So now if you are using UUIDs, because this is one question we have also about primary keys and UUIDs. So there are two problems with UUID. So one is they are random, and then they create more IOPS when we insert them. And they are also very long, and meaning long primary key means long secondary indexes. So here we create a table with UUID, as you can see here, right? The default is a UUID, it's a primary key. So the first 4 records are there. I am inserting some new values there. And when I check, these new values are on top in the table space, meaning that we had to rebalance everything. So if we check later when we have a lot of data there, this is what happens. So every time we do inserts, we are moving everything around, and this is very bad. So storing UUIDs like that in MySQL, it's a bad idea. And so what we should do, and we can see that the length, it's 146 bytes, which is a lot, because every secondary index will have this 146 bytes added to them, right? So we should use a smaller one and a better one. So if you are using UUIDs, you should use binary 16, and you should use the UUID to bin with the swap flag. Because in MySQL, we are using UUID v1, which has somewhere in the timestamp. So what we do, we use a timestamp, we put it at binary, and the timestamp we put it first. So every time we insert new UUIDs, we generate new UUIDs, they are sequential. So when we do that, so this is the UUID to bin. So you see binary code, you can decode them with bin to UUID. And when we do that, we insert the data, and when we insert the data it's after. So it's incremental, and we don't have the issue anymore, right? So this is what we try to do. And like I said, now the index of the primary key is 16 bytes. So for 146 bytes, we went to 16 bytes. So we will reduce the disk space. I was talking about secondary indexes. So every secondary index will contain the primary key at the rightmost column in the index. It's completely invisible. You never see it, but it's there, because we do two lookups when we use the secondary index. One to find the entry in the secondary index and the primary key, and then we look up for the primary key. Bigger is the primary key, longer are your secondary index. And you need to always update them, and it takes a lot of time, right? So here, for example, you can also create prefix. I said earlier you can do prefix of a primary key. And here, for example, you can do create an index part of, and you can decide how many characters you want in the secondary index to make them smaller, right? And here, for example, you have the same index in bytes with, I create an index on the name of the city and then just part of the name. And depending on how you query, for example, here, we always do queries using, for example, send Chris something. So I don't use more than 10 characters in my application. The optimizer will always tell me, oh, the part of index, it's enough. So I don't need the full index. So depending how you query your data, you need to find that. And then it's much faster for the optimizer to use this one, you see. Yeah, we will go out of time, so I want to skip some of them. What does the key length 40? You say, oh, we use 10. And then here it says that we use 40. Why is that? Does somebody have an answer? Yes? You know it. No, go. Yes, it's because of the character set. We are using UTF-8 MB4, so meaning one character use 4 bytes. So 10 for 4 bytes, it's 40, right? So, and this is where the key length will allow you to see how much of the index you are using. So this is what we just say right now. You can index multiple columns, so the first name and the last name, and this is with the key length, and this is also what Daniel explained yesterday, that you need to always use the leftmost. This is because the index is parsed from left to right, and this is with the key length, you will see how many of the entries are used in it, right? But this is, for example, the table, and we see that why we have 124, it's because of the character set, and it's a varchar, we add 2 bytes for the length of the varchar. And we can also check when we use JSON and we create a query, we can see here what, which column in the index we are using, right? Yeah, I will skip this one because I've only 20 seconds left. Like I say, it's a lot. Let's continue with the challenge. So what do you think about these two statements, right? So we do the select, we have the same index we have first. We have none use the index, B, meaning that the left one use the index only, and C, only the right one use the index. So who say hey? Raise your hand. B, 1B, C, 1C, 2C. The other ones are reading emails, which is good too. So it is C, right? So we can see that here we do an index scan on the index. C is used because we are using the order by. So both columns are used, last name and the first name too, right? Yeah, this is for the next. I think we ran out of time. Do you have 2 minutes? I want to show just the histograms. So
okay,
you will
sure.
have.
I think we can give another.
They
couple
won't have
minutes
questions.
So get ready for questions if anyone has questions you want to ask.
Invisible index. We are. Daniel discussed about that. I want to show you something very interesting about the histograms. Yeah. Now in MySQL 8 also we can create index in parallel, which is very nice. And with this change, you can go for 9 minutes. If you do the good tuning to add index to 3 minutes and even 2 minutes. So be aware of that you have settings in MySQL to create index in parallel and to reduce the time of an index creation. So now about the histogram that I was help you. So it is possible to use histograms if you are not able to index a table. In MySQL, we have 2 types of histogram, the statement histograms and the optimizer histograms. And this one is about optimizer histograms, of course. And we have two types, singleton, equi8. So singleton, we have one value, equi8, different ones. And I want to show you the example so you will understand how it works. So here we have a query, right, from a TPCH, big query here. And when we run it, we can run, and you can see that it takes 2 seconds, .3 for the answer, right? So this is the answer. So now I will create an histogram here on the WordPress char count, and I will with 8 buckets. This is the syntax to create 8 buckets for my histograms. And it runs, and then you say it was fast to create it. And now I will run again the query, and you can see that the query went 10 times faster, just because of the histogram. So almost 10 times faster. And so why? Because I will show you why in the next slide. But we use that when we cannot create indexes, because in our case, the WP char count, right? How many characters are in the page? Creating an index of that, it could be very complicated, right? Because it's costly. We need to keep updating it and maintaining it. And if we check this, because the optimizer was thinking, okay, it should be 11% of the page there, but when we check it, it's much less than that. And the histograms will know that. So with the histogram, we will make it much faster. So if you have columns that you cannot index, but you are using them in the workflows. If you don't use in the workflows, don't use histograms. It doesn't mean anything. There is no need for it. But it will help you to go much faster. So that's it for me. So if you have questions on this, the slides, you will find them on the internet. We will provide them here too. And if you have questions or if you want to see other examples, I will be in the MySQL pod all day.
Okay, great. Thank you very much, Fred. That was great. Thank you.